everyone. Today we will discuss more problems based on limits. So if you see this example, limit x tends to infinity, square root of x square plus xa plus a square minus square root of x square plus a square. So you can see again this is an irrational function, but we have terms only in the numerator and we don't have any term in the denominator. So if you don't have any term in the denominator, so we can consider it as 1. So let us say this is divided by 1, and then we will rationalize and again we will proceed further. Here its limit x tends to infinity, so again it becomes an infinity type of question. So after rationalizing we will find out what is the highest power in the numerator as well as denominator, and then we will divide the numerator and denominator by that highest power and we will again proceed further. So here if you rationalize this, so limit x tends to infinity, x square plus xa plus a square minus this, yani we will multiply the numerator and denominator with the conjugate of this. So here we have this plus this and again divided by this plus this. Now if you multiply, so again using a minus b into a plus b, you will get this expression in the numerator and the same expression as far as the denominator is concerned. Here the highest power of x in the numerator is what? X. Simply it is x, so obviously it is x to the power 1 or just x. Now if you see this, so you can just consider, and in the denominator the highest power is square root of x square, which is also x. So divide the numerator and denominator by x. So numerator it was xa, so now it is xa upon x. Here your term was x square plus xa plus a square, so every term it will be divided by this x, but once it goes under this square root sign, so here that x it will become x square because this x square is under this square root sign. So after simplifying we are getting all these values. Now we know when x tends to infinity, 1 upon x tends to 0. Similarly using these concepts, and similarly you have 1 upon x square also tends to 0 when x tends to infinity. So that way we can consider this. Okay, so this part it becomes 0, a square upon x square, that is also 0 because x square, x, they are all in the denominator. So finally you will get this square root of 1 plus 0, because a upon x it will be 0 as x tends to infinity, a square upon x square, that is also 0. So simplifying we are getting this as a by 2. So the limiting value of this question, it is equal to a by 2. So similarly we can see the next question. So if you see this question, so here again this is an irrational. This is again an irrational function, 2x into square root of x square plus 1 a minus of this x. So again we will multiply its numerator and denominator by the conjugate of this, that is square root of x square plus 1 a minus of x. So again here you can say this is multiply in the numerator and this is again in the denominator by the conjugate of this. After simplifying we are getting this relation. Again the highest order we will search out after simplifying. So here in the numerator you are saying 2x, in the denominator we have square root of x square plus 1 plus x. So here also the highest power is x. So again we will divide this. So if you divide again, so you will get 2x upon x in the numerator, again in the denominator x square upon x square here, because again this term goes what? In the under the square root sign. So once it is under the square root sign, so we are having x square upon x square plus 1 upon x square, because x under square root it will be considered as x square. So after simplifying, here it is plus sign. So again 2 upon square root of 1, this is 1, x square upon x square, 1 upon x square, it is 0, so square root of 1 plus 0 plus again x upon x, that is 1, so it is 1, and simplifying we are getting 2 by 2 and that is equal to 1. So this way we can simplify this. See again the next question. So here again this is irrational, but in different part of this the power is different. Here it is just square root of this, so it is 1 by 2. Here it is cube root of this, so it is 1 by 3. Here it is fourth root of this, so 1 by 4. Here it is fifth root of this, so 1 by 5. So how to simplify this type of question? Here also limit x tends to infinity. You can see this limit of this x tends to infinity, square root of x square plus 1 minus cube root of x square plus 1 divided by fourth root of x to the power 4 plus 1 and minus again fifth root of x to the power 4 plus 1 and so on. So again if you observe, this is in this form, infinity minus infinity divided by infinity, infinity minus infinity upon infinity minus this infinity. So if you consider again the highest power, so from here we are getting x, from this x to the power 2 by 3, from this x, and from here x to the power 4 by 5. So highest power is what? X to the power 1 means x. So we will divide the numerator and denominator by this x. Again when that x goes under this square root sign, it will be taken as x square. When it goes under cube root sign, it will be taken as x cube. Fourth root of this, so that will be how much? X to the power 4. Here it will be x to the power this 5. So that we can see here. So here you can see x square, here it is cube roots, x cube, fourth root x power 5, fifth root x power 5. Again dividing all that and considering these relations, considering the relation that when x tends to infinity, 1 upon x or 1 upon x square, 1 upon x cube, that will tend to 0. So using all that concept, we are getting this value. Okay, so you are getting this value. So here you can see 1 upon x square, 1 upon x, 1 upon x cube. All this becomes 0 because x tends to infinity, and we will be getting this relation. So finally this is equal to 1. So we can again simplify putting or using the condition or using the concept when x tends to infinity, 1 upon x or 1 upon x square tends to 0. So that way we can simplify this. So similarly, let us see the next question. This is limit x tends to pi by 4, 1 minus tan x, 1 minus tan x upon 1 minus square root of 2 sin x. Limit x tends, so this is your trigonometrical limit. Now here 1 minus, so I hope you remember all the relations as far as the trigonometrical relation is concerned or the trigonometrical limit is concerned. So we have standard relations for sin theta upon theta, cos theta, tan theta upon theta. We will try to make use of those relations to simplify this. So again here this is an irrational, this part it is irrational. So again first doing any other operation, we will first rationalize the things. So it is 1 minus tan x divided by again 1 minus root 2x multiplied by the conjugate of this in the numerator as well as denominator. So here you can see again 1 plus root 2 sin x upon 1 plus root 2 sin x. So after simplification we are getting this relation. 1 minus 2 sin square x, you can represent it as cos square x minus sin square. Now why we are writing this? 1 minus 2 sin square x, why we are rewriting like cos square x minus sin square x? Just because here we perceive that it is 1 minus tan x, and when you elaborate tan x, that is sin x upon cos x. So sin x upon cos x, so that will give us a factor cos x minus sin x, and when we rearrange this term as cos square x minus sin square, from there also we will get a factor cos x minus sin x. Once you get cos x minus sin x from here and cos x minus sin x from here, those two terms will get eliminated, because when x tends to pi by 4, cos pi by 4 and sin pi by 4, that becomes same. Cos pi by 4 it will be 1 by root 2, and sin pi by 4 also 1 by root 2. 1 by root 2 minus 1 by root 2, that becomes 0. So it means it is in the 0 by 0 form when this x tends to pi by 4. So it means when it is in the 0 by 0 form, when x tends to pi by 4, so cos x minus sin x is the common factor in the numerator and denominator, because of which it attains the form 0 by 0. So we have to eliminate cos x minus sin x from the numerator and cos x minus sin x from the denominator. So just observing this and keeping this in mind, we have rearranged 1 minus 2 sin square x as cos square x minus sin square, and that you can see in the next step. So again tan x sin x upon tan x, so it is 1 minus sin x upon cos x. Here we will be getting cos x minus sin x, that cos x minus sin x indeterminacy will be over. When its indeterminacy is over, then by substituting the value when x tends to pi by 4, we can calculate the required value. So that you can again see here. Okay, so after cancelling out those terms, we are getting limit x tends to pi by 4, 1 plus root 2 sin x divided by limit x tends to pi by 4 cos x, limit x tends to pi by 4 cos x plus sin x. Substituting the value, because when x equal to pi by 4, sin x is 1 by root 2, cos x is also 1 by root 2. Simplifying, we are getting this value. So let us see the next question. Now here we have to calculate when cosec x minus cot x upon x, when limit of this when x tends to 0. We have to calculate limit of cosec x minus cot x upon x when x tends to 0. We can directly simplify the problem keeping this in the same form, but we are more familiar and more habitual in using sin x, cos x, tan x instead of sec x, cosec x and cot x. So we can change it into cos x, sin x and tan x, and then we can proceed further, because the standard relations are there and we feel comfortable to use sin x, cos x, tan x instead of sec x, cosec x and cot x. So keeping those things in mind, you can write cosec x, that will be 1 upon sin x, cot x it is cos x upon sin x, and here we have this x. So sin x is the common denominator here, so this will become 1 minus cos x upon x sin x. Now again you see here, we have multiplied the numerator and denominator by 1 plus cos x. Just because we already have 1 minus cos x, and here there is the presence of this sign, because you have to start thinking what should we do so that we get correct solution as well as the easier solution. So already 1 minus cos x is there and sin x is there. If this 1 minus cos x, I am just giving you the thought process. If this 1 minus cos x would have been 1 minus cos square x, then 1 minus cos square x becomes sin square x, then that sin x and this sin x, it will get eliminated, any one of the sin x from here. So just to make it 1 minus cos square x, we are multiplying numerator and denominator by 1 plus cos x. So 1 minus cos x into 1 plus cos x, that becomes 1 minus cos square x, divided by x sin x into 1 plus cos x. So you have x sin x into 1 plus cos x. Sin square and this sin x and 1 sin x from here, that will get cancelled. Then we will make use of again the standard formula, that is sin x upon x when x tends to 0, that is equal to what? 1. Because once we get this sin x, then we can always use that standard formula. So this x here, this single x here, that can be considered with the sin x. So here we are rearranging the term. So it is sin x upon x divided by this 1 plus cos x. This x here, it has been considered with the new sin x of the numerator. So sin x upon x into 1 plus cos x. This is equal to your 1, because limiting value of f of x upon gx when x tends to a is equal to your limiting value of f of x when x tends to a in the numerator divided by limiting value of gx when x tends to a in the denominator. Means separately we can calculate the limiting value in the terms in the numerator and as well as terms in the denominator, and that way we have used this. So limit of this entire function, it is equal to limit of this divided by limit of this, and that becomes 1 upon 2. Here we are getting 1 cos x when x tends to 0, that is 1, 1 plus 1 it is 2, so finally it is equal to 2. Now let us see this question. Here this is limit of sec 4x minus sec 2x divided by sec 3x minus sec x when x tends to 0. So again we will change it in the cos, as far as the cos function is concerned. So sec 4x, that is 1 upon cos 4x, sec 2x 1 upon cos 2x, sec 3x 1 upon cos 3x, and sec x, that is 1 upon cos x. Just arrange the term and you are getting from here cos 2x minus cos 4x divided by cos x minus cos 3x, that is from this part, into how much? Here LCM is how much? Cos 2x into cos 4x, and here it is cos x cos 3x. So these terms are arranged just like this. The limiting value of this, as far as the indeterminacy of the function is concerned, it is not depending on this, it is depending only on this part. So we have to be do some kind of operation as far as this part is concerned, and there is nothing as far as no need of any other operation as far as the indeterminacy is concerned, as far as this part is concerned. So let us use this relation, because here it is cos c minus cos d. So using this relation cos c minus cos d, which is equal to your 2 sin c plus d by 2 into sin d minus c by 2. So using this trigonometrical transformation, we can consider this term. We can simplify this just using this relation. So you are getting this one. This term remains as it is, because we don't need to change it, because it is not affecting us as far as the limiting value of the function is concerned, because it does not give you the indeterminate form of this entire function. Now simplifying, so this becomes sin 6x upon 2 means sin 3x. Here it will be sin 4x minus 2x means 2x upon 2 means sin x. Here it is again sin 2x. Some of the terms will get eliminated and we will put the values for the remaining term and we will be able to get this value. So again you can see this. So finally, after doing that operation, we are getting these terms. When this x tends to 0, sin x will not be equal to 0, because x tends to 0, x is not equal to 0. That is the thing that we are considering when we consider the limiting values. And when theta tends to 0 or x tends to 0, cos theta tends to 1 or cos x tends to 1. So just using these concepts and these conditions, we are getting this. Substitute the values and you are getting answer as 3 by 2. So putting the value sin 3x upon 3x, that becomes what? 1, because sin x upon x, that is 1 when x tends to 0. So using that concept, this will become 1, 2x upon sin 3x. Similarly, you can consider this. So it is 3 by 2 into 1 upon 1 into 1. So finally it is 3 by 2. I hope this is clear. So we can proceed further. So here in this question you can see we have to calculate the fx is the integral of 2 sin x minus sin 2x upon x cubed, and x is not equal to 0. So find limiting value of f dash x when x tends to 0. So f of x is integration of this. F of x is integration of this entire function, that is 2 sin x minus sin 2x upon x cube dx, and we have to find the limiting value of f dash x when x tends to 0. So this is your f of x. Now we have to first find differentiation. This means the f dash x. So by definition, f dash x, it will be equal to what? The c, because differentiation is the inverse process of integration, or otherwise integration is the inverse process of differentiation. So if this f of x is integration of this, then f dash x will be what? Differentiation of this, and that will remain same as this one. So this is your f dash x. So we have to, so this is just the change of the term. So you need not get apprehensive what language is being used and what I need to calculate. Fx is integration of this, and we have to calculate the limiting value of f dash x. So finally the function remains same. So you are getting f dash x equal to 0. So we have to f dash x equal to this. So we have to calculate the limiting value of this when x tends to 0. Limiting value of this when this x tends to 0. So 2 sin x minus sin 2x, it can be represented as 2 sin x into cos x upon x cube. Again you can rearrange the term. You can take this 2 sin x common, so it becomes 1 minus cos x. 1 minus cos x is what? 2 sin squared x by 2, so it is 2 sin squared x by 2, and divided by x cubes, it is x cube. Sin x upon x, it is equal to 1 we will, when x tends to 0. So we will try to make use of that relation. So accordingly we will arrange the term. Sin x upon x, we need 1 x here. So out of this x cube, we will take this x here. Remaining is x square. Here also it is sin x by 2 whole square. That becomes your sin square x by 2. So sin x by 2 whole square. So again you will need x square there. So 1x for this, another x square for this. Rearrange the term and use those standard relation, and we will be able to simplify this. So here that you can see here. So sin x upon x, sin x by 2 whole square. Here it is x by 2. So we need x by 2. Okay, so we have put it here. Accordingly there it was how much? Only x cube. But when we have used this x by 2, it means you have introduced extra term, and that is 1 by 4. X by 2 whole square means x square upon 4. So 1 by 4 has been introduced extra here in the denominator. So numerator has to be multiplied by 1 by 4. So that is done here. Now substitute, this is 1, this is 1, this is 1 by 4. So finally you are getting this value. Simplifying, because 4 is here, 4 is here, that will get cancelled. So only this 1 will remain. So limit of f dash x when x tends to 0, that was to be calculated, and that is equal to 1. So this is your answer. Now in this question you can say limit x tends to 0, 5 sin x minus sin 2x plus 3 sin 3x divided by x square sin x. Now the best way is, it is in the 0 by 0 form, because x tends to 0, and when x tends to 0, sin x tends to 0. The best thing that we will be using is sin x upon x when x tends to 0 is 1. So we will try to rearrange all these terms in that form. So sin 2x here, that can be rearranged 2 sin x into cos x. Sin 3x is 3 sin x minus 4 sin cube x. 3 sin x minus sin cube x. Now these things are done so that if there is a possibility, right at this stage we don't know, but if there is a possibility that we can take sin x common from the numerator, then there is a sin x in the denominator. So that sin x in the numerator and this sin x in the denominator, that will get cancelled out, so that it will simplify our problem. So that is the intention behind this transformation. So here you can see sin 2x, it is 2 sin x cos x, sin 3x is 3 sin x minus sin cube x. Replacing that term with all these terms, we are getting sin x from here, sin x from here, sin x from here. So sin x can be taken out from the numerator. So here it is your 7 into 2 sin x. So that is minus of 14 sin x cos x minus 12, 4 into 3, 12 sin cube x, this sin cube x. So after simplifying, we are getting this term. So take this sin x common. After taking this is the remaining factor. Sin x is here, sin x and sin x, that will get cancelled, because when x tends to 0, sin x tends to 0, sin x is not equal to 0. Again, always you have to keep these conditions in your mind when you do any kind of operation, otherwise sometimes you may get a wrong relation. So after simplifying and after cancelling out this sin x and this sin x from here, you will be getting this relation. Now 1 minus, because here it is x square and here also you have sin square x, sin x upon x whole square, that will absorb x square, because sin x upon x, when x tends to 0, that is equal to 1. So when there is a sin square x here and when it is x square in the denominator, so this 1 minus cos x, again it has to be converted to sin square x, then the entire form it will be taken as sin x upon x whole square. So this x square will be absorbed, this sin square x, that will also get absorbed, and 1 minus cos x, that will also get changed to sin square x, so that will also get arranged as far as the standard relation is concerned, and that's why we are changing this 1 minus cos x as to sin square x by 2. Now again this x square, so this divided by x square, this divided by x square, it is coming in the standard form. The only thing is here you have x by 2. So again that extra term 1 by 4 will be reintroduced. Once it is introduced, to eliminate that, we will again arrange that 1 upon 4 either in the denominator or in the numerator depending on our requirement. So here you can see this sin x by 2 upon x by 2 whole square. It means we are dividing numerator by that extra term 1 by 4 here. It means this numerator has to be multiplied by 1 by 4. So this is multiplied by 1 by 4 minus of this 12. So sin square x upon x square. So this is your sin x upon x whole square. Simplify the value, substitute the values and simplify it, and we are getting this as minus 5. So limiting value of this function, it is equal to minus of 5. Now let us see the next question. We have this 5 theta minus 2 sin theta upon 3 theta plus tan theta when theta tends to 0. So if you see the problem itself gives you the solution. Most of the thing it is in the standard form, tan theta upon theta, sin theta upon theta. Those are the standard limiting forms. So we can just divide the numerator and denominator by what? Theta. So if you divide the numerator and denominator by theta, then we will be able to make use of that standard relation. So after dividing this numerator and denominator by theta, 5 theta cos theta upon theta. So this theta will get eliminated. Cos theta, when theta tends to 0, it is equal to 1. Sin theta upon theta, when theta tends to 0, it is 1. Tan theta upon theta, when theta tends to 0, is 1. 3 theta upon theta, theta will get eliminated, so it remains same as 3. So you can just see here. So we have done this 5 theta cos theta, 2 sin theta upon this, 3 theta upon theta and tan theta. All are in the standard form. Substitute the values and get your relation. So you can just see here, all these terms are eliminated and remaining are in the standard format, simplifying the value, and we are getting this 3 by 4. So the limiting value of this function, it is equal to 3 by 4. Now if you can see the next question. This is 1 minus sin x upon pi minus 2x whole square when x tends to pi by 2. So we have to find the limiting value of 1 minus sin x upon pi minus 2x whole square, x tends to pi by 2. Now see some of these standard assumptions, because here all our relations are when x tends to 0, theta tends to 0 in that, but here x tends to pi by 2. So we will replace it, we will substitute in such a manner we get that standard format, because if it is the limiting value or the function, if it is in the standard format, then only we will be able to make use of those standard relation. So here x tends to pi by 2, so you write pi by 2 minus this x tends to suppose h, because when x tends to pi by 2, this pi by 2 minus x will tends toward 0. So in that case, this h will tends to 0. That is the intention, just to arrange term in the standard format. There is no other intention except this. So accordingly you can consider this pi by 2 minus x, because x tends to pi by 2. So you will write pi by 2 minus x. X tends to pi by 2 means pi by 2 minus x is equal to suppose h. So when x tends to pi by 2, this will tends to 0. So when this tends to 0, my problem gets converted into the standard format, and then only I will be able to make use of those standard relation. So here from this you can consider all this. So you can take LCM, or you can leave it in this form, and you will get pi minus 2x equal to 2h. When this x tends to pi by 2, so this becomes pi minus pi, that is 0, so that h tends to 0. So now let us come back to our problem. So this is limit x tends to pi by 2, 1 minus sin x upon pi minus 2x. So your pi minus 2x, we have calculated how much? 2h. So that becomes your 2h square. Sin x, x is equal to how much? Pi by 2 minus h. Sin 90 minus theta is cos theta. So we will make use of that relation. So this becomes 1 minus sin, cos h. So 1 minus cos h, this is 2h means 4h square. 2h whole square, so that is 4h square. Again in the denominator you have h square. And again we need what? Sin x upon x. But in the denominator we have x square. So in the numerator also we will need sin square x. And that we are getting from this relation, because 1 minus cos h, again that will be equal to how much? 2 sin square h by 2. So that gives us an opportunity to rearrange the term, so that we can rearrange terms in the numerator as well as denominator. So it is twice of sin square h by 2 divided by 4h square. Again here you require sin h by 2 upon h by 2 whole square. So when in doing so h by 2 whole square, you are getting h square upon 4. Again that 4 by 4, it will be an extra term that is being introduced. So you have to take care of that. So arranging these terms and substituting the value, you are getting it as 1 by 8. So answer of this question, it will be 1 by 8. So now if we see now see the next question. So this is again, here we have numerator again in the irrational. So again we will try to simplify that. So this is limit x tends to pi, square root of 2 plus cos x minus 1 upon pi minus x whole square. See here, already this gives us a clue. This is pi minus x. Here already x tends to pi means we already have a term pi minus x, because when x tends to pi, pi minus x will tends to what? 0. So if you consider again pi minus x equal to h, so when x tends to pi, this h will tend to 0, and again we will make use of that relation. So this is limit x tends to pi, this expression is equal to limit h tends to 0. Now the entire thing it is getting changed to h. So limit h tends to 0, twice of cos x. X is equal to how much? That will be pi minus h. So cos pi minus h. Minus of 1 here, so it is 1 here. And pi minus x whole square means how much? H square. So we have this h square. Now again simplify this. So cos pi minus h, that is same as what? Minus of cos h. Cos pi minus theta, it is minus of cos theta. So using that relation, we are getting minus of cos h. This one is already there, divided by h square. Now at this stage, we will rationalize. Either we can rationalize here, or before starting this we could have rationalized this. That is again up to you. Either you first rationalize and then proceed, or first simplify and then rationalize. So again we will multiply the numerator and denominator with the conjugate of this term that you can see here, and we will simplify it. So now you can see this again. So after simplifying, we are getting this relation. 2 minus cos h minus 1 upon h square into 1 upon this. This term we are getting after rationalizing. So again we are getting how much? 2 minus 1. So that becomes again your 1. So 1 minus cos h divided by h square into 1 upon this is square root of 2 minus cos h plus 1. Again 1 minus cos h, it will be converted to what? Sine. So 2 sine square h by 2, because h square is here and that will take care of this numerator part, into 1 upon divided by this, 1 upon this expression. So it is limiting value of again this function when h tends to 0, sine h by 2 whole square. Here again you will require h by 2. After in doing so, we are introducing again 1 by 4, so we will multiply it by 1 by 4, because that 1 by 4 has been introduced in the denominator. So cancel out that, we have to multiply the numerator also by 1 by 4 into this. Now putting sine theta upon theta, again when theta tends to 0 is 1, so this part becomes 1, this is 1 by 4, so 1 by 4, already 2 is here, so you have this 2, 1 minus cos 2 minus cos h, h is 0, so it is cos 0, cos 0 is again what? 1, so 2 minus 1 it is 1, 1 plus 1 that is 2, so that you can see here, and finally it is 1 by 4. So limiting value of this function, it is equal to 1 by 4. So after simplifying so many questions, we are observing if there are irrational terms, you have to rationalize. If x tends to some other number instead of x tends to 0 or theta tends to 0, so we have that kind of substitution, so that again we can, after that substitution, we can rearrange the terms in the standard form, that is sine theta upon theta, tan theta upon theta, or simply cos theta when theta tends to 0, that is equal to 1. So these are the clue that you should always keep in mind. What is the format, what is the standard format, what are the substitutions that I need to do, so that the problem gets converted into the standard format. So these are the things that you can keep in mind, and once you have these things in mind, the problems, any type of question, whether it is easy or tough, that becomes simple question. Now in this question, if you see again, here again if you see, limiting value of this when theta tends to pi by 4, and the function is what? Square root of 2 minus cos theta minus sine theta upon 4 theta minus pi whole square. So here again this gives you what? Again you assume either theta minus pi by 4 or pi by 4 minus theta is equal to alpha, beta, gamma, h, whatever you want to take it. So again we can consider this root 2 minus root 2 cos, this sine cos theta minus sine theta, here it has been represented as cos theta minus pi by 4. Why it is represented like this? Just because in the next step we will take pi by 4 minus theta, or we will take theta minus pi by 4. So either you do it here, do some changes here, or you assume that theta minus pi by 4 is equal to h, or pi by 4 minus theta is equal to h. When theta tends to pi by 4, h tends to 0. So you will be automatically, you will be able to arrange it in this form. So once you understand certain thing, you can have some shortcut solution. So directly we have tried to do here just to minimize the number of steps. That is the only intention. Otherwise what we will do, again we will consider pi by 4 minus theta is equal to h. When theta tends to pi by 4, this h tends to 0. Wherever there is theta, we will introduce it as pi by 4 minus h, and again simplify that. That is the intention, just to minimize some of the steps or get out of some of the steps, and directly we can put it. You can do all these steps, come to the conclusion, or directly, because cos theta minus sine theta, how it is written here, cos theta minus sine theta, you can write like that. Just multiply both the term by 1 by root 2 and 1 by root 2. And here it will be root 2. Because we have multiplied by 1 by root 2, so you have to divide by root 2. So finally you are getting this. This 1 by root 2 you can take cos pi by 4 or sin pi by 4. Again this 1 by root 2 you can take cos pi by 4 or sin pi by 4. Using this concept, use the relation cos a minus b or sin a minus b, simplify, and you will be able to get this relation. So either you go for this, or you have all these steps simultaneously, and you will be able to get, finally we will get the same thing. Now here again, so after simplifying you are getting root 2 upon 16 limit theta tends to pi by 4, limiting value of this when theta tends to pi by 4. So 1 minus, taking this root 2 common out of it, 1 minus cos theta pi by 4 divided by theta minus pi by 4 whole square. Again cos 1 minus cos theta, that gets converted to what? Sin square. So here it will be sin square in the numerator, and this is again x square. If you call it as x, this is x square, and here it is, if it is sin square, then again that sin x upon x formula comes into picture. Using that we will be able to simplify it. So use these steps, simplify step by step, or directly if you can do it directly, you can arrange this cos theta minus sin theta in this form. You will get this relation. You know that 1 minus cos theta gets converted into sin square, and we will make use of that relation. So here you can see that. So again see this here, 1 minus cos theta, that has been changed to 2 sin square theta minus pi by 4 upon 2, again theta minus pi by 4 upon 2 whole square. When again you have done it as whole square, so again we are introducing 4 here, so you have to multiply. Here in the denominator of this part we have introduced this 4, so we need to multiply this 4, so that 4 and 4 gets eliminated, and after you are getting this, substitute the values as we have discussed, and finally we are getting it as 1 upon 16 root 2. So this is your solution.